in Urban Studies and Planning, and I am guest introducing today for the seminar. I'm also director of OTREC. Welcome, everyone. We have a special visitor with us this week. It's Professor Greg Lindsey. He's with the Humphrey, I'm always going to get the Humphrey School of Public Affairs. There is also a Humphrey Institute within there. He's just finishing up his time as being an associate dean there in the Humphrey School, and he's taking some time off and getting re-engaged in his research. He is one of the leading researchers in this country on non-motorized transportation data, particularly data related to trails and off-street paths. And he's been doing some great work in that area, both in Indianapolis and now Minneapolis, where he's been for the past few years. I'm going to turn it over to him, but before I do that, I'm going to remind people, for those of you who might be new, we do webcast the seminar, which is why I'm standing here with this microphone that doesn't project. After Professor Lindsey is done with his talk, we'll have time for questions at the end. And when we are doing those questions, one of us will come around with this microphone so that the people watching on the web, and there are always people watching on the web, so they can hear your question. So without further ado, I'll turn it over to you.
Jennifer, thank you very much. It is a pleasure to be here, and it is a pleasure to re-engage with research after 9 years of serving in the administrative positions at Indiana and Minnesota. I feel it's also an opportune time because Krista Nordbach spoke yesterday, and she covered a lot of ground, and she introduced a number of issues. And so I know that many of you were here for her talk, and I think that this work will complement it nicely. I'm going to talk about building evidence for active travel and counting and modeling non-motorized traffic. And I'm going to share with you some of the work that we've done in Indianapolis over time and more recently in Minneapolis. And all this is sort of work in progress. I'm working now on a project with the Minnesota Department of Transportation to explore strategies for trying to improve data collection and integration of non-motorized data with their vehicular data. And so this is an ongoing work, and it's also, I think, something that many states are looking at trying to do. I'm going to talk a little bit, very briefly, about the motivation for research and provide a couple of examples of why I think it's important that we do a better job of trying to collect information about non-motorized traffic. I'm going to talk a little bit about modeling non-motorized traffic. I won't do as much in detail on adjustment factors or estimating bicycle miles traveled as Krista did yesterday, but I'll talk a little bit about this. And at the end, I'm going to talk about why I think it's important that we try to collaborate in this work, because I think shared approaches to analysis of these types of data can help move us forward much more quickly. Now, not quite 20 years ago, 17, 18 years ago, when I was an assistant professor at Indiana University, Ray Irvin, who had been a city councilor, and sponsored an ordinance to create a greenways trail system in the city of Indianapolis, said, Greg, we need to figure out how many people are on our trails because people are questioning whether these investments are good. And that led to a capstone workshop with several students who went out and sampled. And over time, it led to a set of studies. And so the motivation for this is a very practical one. It's because local decision makers, state decision makers need information, particularly in these times of austerity. Last year, the state of Minnesota was looking at a $5 billion deficit. Indiana simultaneously was looking at a $1 billion deficit. And in light of that austerity, people need to know that they're making efficient investments. So this has been the motivation. Krista spoke yesterday about reasons to try to document bike and ped traffic. And so there's a set of those. I think all of you would be familiar with those. So I won't go over that. But the three I put in bold, I want to give 3 examples. So let me go to those because I think that they're illustrative of the types of reasons that we want better information. These are the types of facilities that people are building. These are multi-use trails in Indianapolis. The one on the left is a rail trail. It's called the Monon Trail. This is called the Canal Towpath. This is the principal drinking water supply for the city of Indianapolis. So this was an 1834 canal. This is a trail on top of a levee designed as sort of a City Beautiful system by George Kessler, one of the City Beautiful architects, and this is another part of a park system. So you can see it's typical sorts of facilities. And at one point there in the mid-2000s, we had about 30 infrared counters out on basically every mile of the then existing system. And what this graph, what this map shows is both the spatial and temporal variation in the system. And this is for the month of September, and it shows the mean weekday and mean weekend traffic. And you can see those are distinguished by the colors. And it reads, what it does, I think, is illustrate the types of questions we can answer when we begin to obtain information. So for example, here you come down the canal towpath, and then you see a big drop in traffic. This happens to be 38th Street. Why is that? We see down here on Pleasant Run, which was one of the images I showed you, much lower traffic than any place else. And why is that? Here's the Central Business District. If the city went ahead and connected this loop, would that create greater traffic, or could they connect it this way? There's a lot of questions we can ask and information we can begin to desire once we see how traffic flows. You can also start to get ideas about typical use facilities. If this is the CBD and here's the largest volume, it's pretty clear, and these are getting lower as you come down closer, it's pretty clear that some of this isn't a commuting route, right? There are different uses that are there. So we can start to draw inferences, make hypotheses. So this is an example of the type of information we'd like to have so we can begin to understand our system. In another case from Indiana 6 or 7 years ago, and these types of issues would be, I think, more severe now, the State Department of Transportation and DNR had about $10 or $11 billion to allocate statewide for investment in trail facilities. They received 66 applications for more than $73 million. They didn't require projections of potential use. In other words, no measures of demand. And it's sort of, we can't imagine building many public facilities or investing in much public infrastructure without measures of demand. But in this case, that was the case. 20 applicants did put in some projected measure of use, and the mean predicted annual traffic was 22% higher than the highest volume we ever measured in the city of Indianapolis. Okay, so if we go back here, their mean projection was 22% higher than this for those people that bothered. And the reason is that they have no methods for thinking about this, and so there's a lot of wishful thinking. And so the experience there was, to the extent that people are beginning to think about demand, they lacked methods. And so in other words, and they weren't even grounding those estimates in sort of transfer of volumes from other places. And so again, we think that helping people figure out how to measure use of facilities can help improve operations. And this is a more recent example of the way that the city of Minneapolis is beginning to use traffic count data from trails. They have on a greenway, it's a rail trail conversion called the Midtown Greenway that runs east-west through the city. They've an automatic bicycle counter. They've had it there for, they have 3 of them from 2007 through 2010. And the trail intersects a number of local streets. And after they analyzed data, they looked at the daily bicycle traffic and compared that to street traffic. And they went through and did these, they made these changes. They removed the stop signs off the trails, they added them to the street, and they did a little bit of other improvements to try to smooth out flow through that system. And the entire idea of giving preference, or in this case to the bicyclists and pedestrians, was based solely on volume of use. And so people are beginning to think about how they can use this information to improve operations overall. Now, historically, there's been very little federal government involvement in traffic, and I think it's useful just to compare briefly the distinctions in how traffic monitoring occurs. At the federal government, the Federal Highway Administration sets standards in the traffic monitoring guide and helps fund, and the state DOTs implement, and locals collaborate. In the bike and ped system, there's been little federal involvement, though this year there will be a chapter in the traffic monitoring guide on approaches to measuring bike and ped traffic. Few states actively count. For example, Colorado, Washington have begun in certain types of counting methods. There's a national project between Alta Design and Institute of Transportationeers that's set up a sort of a standard approach that do short-time manual counts. And now the National Academy's Bike and Pedestrian Data Subcommittee of TRB is beginning to do work on trying to establish better methods. But overall, the thing that's distinctive here is that there's been more of a bottoms-up. Local jurisdictions, regional in some case, have begun monitoring, and they're the ones who've paved the way and developed better guidance. And states are coming around now and beginning to try to figure out how they can support those efforts so they can work with other jurisdictions across the state. And that's an example of a project that we're doing in Minnesota. Here's a Minnesota situation. Minnesota maintains 32,000 sites in their traffic monitoring system, 1,000 reference sites for vehicles, 31,000 short duration 48-hour counts. They rotate through those on a 5-year rolling basis. And local governments like Minneapolis and St. Paul, the larger cities, would augment that with a lot of other initiatives. MnDOT presently has not been involved in bike and ped counting at all, though they will be buying some technologies and deploying those in the coming year, more as pilot and demonstration projects to illustrate methods. Local governments and nonprofits are monitoring at a number of sites. Most of those follow the National Bike and Ped Documentation Project, and mainly it's been the Minneapolis Department of Works and a nonprofit, Transit for Livable Communities. We've been able to work with Park District and put in a number of continuous automated counters on trails. So the state is evolving the system, and I'll sort of share with you where we are in that effort overall. This gives you sort of a picture. Most of what goes on in manual field observations in Minneapolis, and they've measured on both streets, some bike boulevards, sidewalks, and multi-use trails. It's really only here where in our state that they've been able to begin using automated counters. And where the state is going to go is starting to think about deployment of newer inductive loops, maybe video with automated processing in streets, because this is where we lack a lot of information, and we also lack information on sidewalk traffic. So that's the direction the state wants to go, because in other places, park districts and other units have been able to move ahead here, and at least there's some information available. So the state's trying to think about this, about their engagement from more of a pilot strategy to demonstrate what's moving on, how jurisdictions can move ahead. Our objective with working with counts is to understand patterns. We want to understand variations by mode, both bike and ped. We want to understand temporal variability and spatial variability, and we've already seen examples of that with the one picture from Indianapolis. So I'm going to go through very quickly a couple of examples, and the objective here is to illustrate, and then we can engage in some conversation, because I think this is an area where shared experience can really help people improve approaches to what we're doing. I'll give examples of results from monitoring of multi-use trail traffic in Indianapolis and Minneapolis. In Minneapolis, there's been, I'll try to illustrate some of the challenges working with different types of counters that are deployed simultaneously. And then I'll give an example of some of the work we've tried to do with the Minneapolis Department of Public Works and the Transit for Livable Communities short duration counts, and illustrate some of the challenges of working with these types of purposeful samples. So I'm going to go down thinking about estimating annual traffic, and there's sort of a general approach about establishing continuous sites, thinking about quality assurance and control for the counters that are in place, and how we know that they're actually measuring what they're measuring. If we want to come up with a full daily record, we have to think about imputing missing counts, and we can use models for that, and I'll talk about that a little bit. We can estimate or calculate the average annual daily cyclist or pedestrians, then move up with adjustment factors. And as Krista focused yesterday, we can then use those adjustment factors to extrapolate short duration counts at other locations. And with the models, the statistical models I want to talk about, again, the challenge is to have sample locations. Quality assurance is important. We're going to want databases of correlates of traffic, built environment, sociodemographics, other factors that matter. We'll estimate some regression models, and then we'll see how well we predict. And so we're going to follow these general approaches to thinking about working with the counts and coming up with information. This is Minneapolis and Indianapolis. And so I'll spend a little bit of time illustrating here. This work now is probably from 2004, 2005, and this was about a 33-mile network of trails. This is part of the trails that are existed, not, you don't have the planned trails here. And again, this is a central business district. And at this point, we had about one infrared counter for mixed mode traffic, undifferentiated pedestrians and cyclists, on about every mile of this segment. And each of these neighborhoods we defined as about a half mile from the counter location on the network to go from the trail out through the street network. And we wanted to collect information about those neighborhoods to see how those types of data in those neighborhoods would correlate with the volumes of traffic that we observed over this location. So that's Indianapolis. Here, the Minneapolis Park District, Park and Recreation Board, which is separate from the local government, maintains about 50 miles of trails, and the Department of Public Works and other city agencies maintain other trails. This is downtown Minneapolis. This is the university. This is the Mississippi River. So you can see there are trails on both sides of the Mississippi River. This is one of the major arterials that comes from the airport. And then the Park District is renowned for what's called the Grand Rounds. And it's a series of about 7 lakes. Each of these are about 3 miles in circumference. And there's a trail system that goes all along this route. And so this is about a 20-mile loop if you were to go out and do this. And the city of Minneapolis has maintained bike counters at this location, and this location. And we've supplemented that with infrared counters at each of these 3 locations and then monitors here. And one of the goals that we have is to move in the coming year is to maintain about 3 reference sites and then try to sample for a 2-week period every mile segment of this system. So that's the direction we're going with the research. And what I'll be sharing with you is what we've got so far from 2011 data out of these 6 or 8 counters. Now, one of the challenges is calibration. And I want to go back here. This location, and this location, we have both an infrared counter, which counts bikes and peds, and there's an inductive loop counter. The EPW put in the loop counter in 2007. The people that put them in have moved on. The people that have inherited them aren't quite sure how they're operating. And so the first time we took data out, this was in 2009, 2010, and plotted them against each other. Here was the result. And that is, virtually every day the bike count is higher than the bicycle and pedestrian count. Okay? So this is a challenge, and this is the sort of thing that you come up against when you begin to think about how you're going to cobble together a system and use different types of technologies in tandem in order to get much more information. So, and the reason this has occurred is because there's different magnitudes of error with each type of device. This is the inductive loop counter, and we have plotted on here are the so we had students in the field who would spend hours counting the bikes and peds as they go by, and then look at what the counter was giving us, the readings, because this is the sort of thing that Department of Public Works hadn't resources to do. They were using the numbers they were getting out of the machines as indicators. In fact, the numbers that they use to justify the stop sign switches, they come from this one, where there's a 30% overestimate of the number of bikes that are there. Okay? So we looked at this, and the students, each of these represents an hour, and so they were watching for an hour. This is the loop detector, and this is the actual count. And if we want to relate those, you can see that we have to reduce the projected counter by 30% to get what we actually think. So one of the challenges here, when we're going to work with counts, is to do validation in the field, because otherwise we can have numbers that really don't make sense. The difficult thing here is they put 3 counters in at the same time. One overcounts, one undercounts slightly, and one undercounts slightly, one overcounts, and one overcounts a lot. Okay. Now we have, over here we have plotted all 3 of they happen to be Trail Master. These are counters I had taken from Indianapolis with me at the 3 locations on the Greenway. And you can see that they're all plotted on the same line, and basically there's a consistent undercount there, and that comes from general occlusion. It's an active infrared counter where people break a beam. And if 2 people go by side, you're only going to get 1. So one of the choices that I think we have to make in beginning to monitor bike and ped traffic is how we're going to manage data from data from counters and whether we're going to validate it and what sort of procedures we're going to use for that, because they will be different. I had a conversation with a federal highway official who said that basically when they work with vehicular data, they accept whatever the counter says. He said, we don't make up counts. What we've chosen to do is develop correction equations for every hour of count, and we multiply those times the hourly count to get an estimate that we think is much better. And so all the data that I'm going to show with you are adjusted with these correction equations for every hour in the data set, just to give us a better sense of where we think is going on. And the logic of doing this, the logic of putting the infrared counter with the bike counter, is that theoretically, if we can subtract the bike counts from the mixed mode counts, we can have a ped count, right? Well, when we do that, even after we apply these correction factors, we still sometimes get negative pedestrian counts. Okay? So there's a challenge in working with the information, and we have to decide how we want consistent procedures for handling those, because if we don't, then as we begin to amass data, particularly at the state level from different types of places, we'll have apples and oranges in our data sets. So this is just illustrative of the data that comes out of these. This is all Indianapolis data, and this is what a one-year complete record looks at. In Indianapolis, the maximum daily count was 61.55, the minimum 52. The gold here is the average monthly weekend daily traffic. And the magenta or the pink is the average daily weekday traffic. And so you can see that weekends are a lot higher. Here we've done the same sort of phenomena, but what we've done is plant the mean daily traffic. This, again, mixed mode. This is over a 4-year period, 2004 through 2007. And what you see Saturdays and Sundays and then weekdays, and you see a drop-off towards the end of the week. And actually, we're seeing this same sort of a phenomenon in Minneapolis, where Friday ends up being one of the lowest days. And we had a discussion in Jennifer's class the other day about reasons that occurs. This is on one trail in Indianapolis. This is about midway from to downtown, which is 38th Street. And so you can see there's about a 7-fold difference in trail traffic over a 3 or 4 mile stretch of that mixed-use trail. And so one of the questions, again, is why does that occur? You can see the seasonality here, and you can see interesting things. This 38th Street happens to be a section of the trail adjacent to the State Fair. And the State Fair runs for 2 weeks in August. And what you see is this, you can see they promote bike to the fair, and you can see a big bump there. And then you can see this is at a couple different locations. These are the 24-hour traffic patterns. This happens to be for September 2004, but you see the weekend pattern and the day of week pattern. And you see, as Krista showed us yesterday, sort of the morning and afternoon peaks, which could indicate utilitarian use, but you can also imagine after-work recreational use. And this is a lower traffic volume, not as clear a sight. So this is the information we can get, and from this we can start to reduce it to come up with adjustment factors, sort of look at these in relation to annual average traffic to see how we're going to move forward. So there we have a lot of information that's been helpful for the Indy Parks for managing their system. Now I'm going to switch to Minneapolis, and to give you an idea of the same sorts of data and the way that we're working with it. So this is mixed mode mean monthly data at the 6 locations where we have those sites. And 2 of those locations, there are separate trails for bicyclists and pedestrians for 8 months of the year. In the winter, they only plow 1, and so then we have mixed mode. And so these are the types of, again, practical challenges distinguishing mode throughout the year. But here you have 6 sites. This is Lake Calhoun. This is a connector trail between 2 parks. This is month of the year, and this is mean daily traffic. And so it runs from it's about an order of magnitude. At Lake Calhoun, around Lake Calhoun in the summer, the mean daily traffic is over 7,000. But this is, I think, which is an interesting thing in terms of thinking about patterns in the data. This is mixed mode, monthly, annual, daily traffic. And this is the month. And this is the ratio to average annual daily traffic. And so you take these 6 sites, and with the exception of Cedar, around one of the locations on the Greenway, the ratios are quite similar. And so what that suggests to us is that there are comparable factors that are affecting use. Again, this is mixed mode. In other words, for mixed mode traffic, in January or July traffic is about 2.25 times the average annual daily traffic. And it's these types of factors that enable us to begin to use the ratio method or the factor method that Krista described yesterday. Because we have separate counters on the separate bike and ped paths around a couple of the lakes, and also because we have those at two sites on the Greenway where we've subtracted bicyclists from mixed mode to get peds, we can start to separate out those factors, and you can see here the importance of distinguishing between bicyclists and pedestrians. Here, the July monthly average daily traffic to the annual average daily traffic is about 2.5. For pedestrians, it's a little under 2. And so these lines are those. And so by separating it out, we can see that there is different seasonal variability by mode, and that's useful to understand in terms of thinking. And then we can also separate out by type of facility. The Greenway Trail, again, is the one that's a straight shot east-west, and that's used a lot more for commuting. And you can see that the weekend ratio is 1.2 to the average annual daily traffic, but around the lake trails, it's 1.4. So our inference there is there's a lot more recreational. And that's, when I talk about this with my dad or mom, they'll say, well, duh, we could tell you around the lake there's going to be a lot more recreational traffic, right? But the point is, what is the magnitude of that? And so developing these ratios helps us begin to understand the relationships between mode, space, and time. And the better we can characterize that, the better we can understand the rest of the system overall. And so we're working on, these are things that will are just coming out of the 2011 data. And we can also look at weekends and weekdays. And this is the Greenway, and this is around the lake. And one of the questions we were discussing yesterday is, how do you develop factor groups? For example, if you have a multi-use trail, is it a commuting route or is it a recreational route? And can we develop quantitative criteria? We don't have those across the country yet. And so if we're going to develop different factor groups and say, okay, we're going to generally think about this facility as commuting, this is utilitarian, or another one's recreational, we aren't there yet. You can see that on the Greenway, on the weekdays, they're very similar around that rec trail, but on the weekends they're different. And so one of the questions is that different enough to consider it a different sort of a facility, and how do we use those measures overall? Krista noted yesterday that it's not a good idea to compare volumes across cities in any sort of an approach, but it is useful, I think, to look. So if we look at the volumes that we measured across 30 sites in Indianapolis 2004, you can see that there are different volumes here. The mean traffic across the 6 sites where we've begun to monitor in Minneapolis is higher than the largest site there. And it gives you an idea of the difference in volumes of how people use facilities. And so there's also a reason why we don't want to think about volumes achieved in one jurisdiction as indicative of what they may be at another one. What I do want to do, the information that's useful here is to look at the locations where we've tried to separate out bike and ped from mixed mode, either by monitoring separately on trails or subtracting bikes from peds. And you can see one of the things that's very different around these trails is on the Greenway, it's predominantly bicycles. And around the lakes, it's 2/3 of all the traffic is pedestrians. And so you can see large mode shifts, large different types of use, even though patterns sometimes look quite similar. And so this is helpful to the DPW and parks as they try to plan for that system. I want to talk some about factors that affect trail traffic and the approaches that we've used in Indianapolis and Minneapolis to try to understand why some of the variation occurs. So we can think about weather, we can see seasonality, we can think about day of week, neighborhood sociodemographics, built form, and try to understand whether these correlate with, whether neighborhood characteristics correlate with traffic volumes that we've observed. And what I want to do here is illustrate just a couple points. The numbers aren't very important other than they say that all these variables matter. we have a couple of approaches. One is a general model where we're going to say that we're going to look at the volume of mixed mode traffic as a function of the sociodemographic characteristics of the neighborhood, the built environment, weather conditions, temperature, precipitation, wind, day of week. And over here, we're going to develop site-specific models, and where we're just going to look at weather. And the reason we want a couple different approaches, this type of a model might be useful if we wanted to try to predict at another location what traffic would be, were a trail to be extended here. Here, if we're missing days and we want to predict a volume to round out an entire annual database, we can use these types of models to fill in missing observations, because what we're doing is estimating those from the site itself. These are negative binomial models. If we do it with OLS, we're explaining about 80% of the variation in the daily traffic with these models. And then what we can do is try to predict. And so what we've done is taken a week. This is just illustrative. And we've taken a week and using our statistical models to try to predict. This is a Sunday through a Saturday. The green is the actual traffic. And this is what our three models would predict. This is Minneapolis. And you can see we're underestimating on the weekends here. We've not done so well around Lake Calhoun. Other places, it's not bad. So we're, again, first-generation models for these places is what we've been able to do. In Indianapolis, these are several years old, comparable models. We explored with a lot of things. I was working with a geographer who was very interested in things like looking at the relative amount of tree cover on the trails versus the neighborhood in which it was located in. We found, for example, this variable was positively correlated. But in terms of practical significance, not great. We were using LiDAR data to try to look at the viewshed for the particular trail. And we found that openness of viewshed was correlated with trail volumes. But from a transportation perspective, trying to think about volumes you want to, or trying to predict, it's not really critical. So we've done more simplified models, and we can generally explain a fair amount of volume. But one of the things that I'm interested in is how bad of a model we can produce and still be useful, because that may sound like an odd thing to say, but I was a division chief at Maryland Department of the Environment. That's how I got through graduate school. That's how I financed my graduate work. And we were never in a situation where we could develop an optimal facilities. We were always trying to satisfy. And so one of the questions is, if we're going to specify a model, we can specify a very thorough model, but the effort to get to that, for example, to integrate LiDAR information to each of our models for trail traffic, it's not very practical. And so this is just an illustrative of whether or not we can step back from a more fully specified model to do a simpler one and see what we give up in terms of our ability to predict. So for example, here, this was at Indianapolis, and we were trying to predict at one location for a week. And here's how we did. The blue is the actual, the purple is the predicted account. And again, what we tend to do is underestimate on the weekend larger volumes. This happens to be the site in Indianapolis with the largest traffic volume. This is the one with the smallest traffic volume. And one reason we did this is because sometimes when there's very small volumes, it's easier to get larger errors. And you can see some days you just miss, and we don't know why that occurs. In this particular case, instead of working with the street network as the half-mile via street network as, if you will, the user access zone to assemble all our sociodemographics, we said, what if we just use a census tract? Because that'd be simple, right? And we used as simple variables as you can get. And this is what it does to our ability to predict. You can see we get worse overall, particularly at this site. We don't do very, very good at here if we just look at trying to correlate traffic volume with census tract characteristics of the sociodemographics. And we eliminate urban form variables. And so one of the challenges is, like, how much information do we have to assemble if we're going to use a statistical approach to help local jurisdictions get some idea in ballpark of what traffic they may have. And this is illustrative of that. When we average these point estimates, and Krista yesterday was talking a lot about sort of magnitude of error and the confidence. I'm not going to talk about that today. You can see we're in this range for some of the models. So we're beginning to improve. That's the trail traffic, and they're the easiest data to work with because you have more limited access to the facilities. There's less variation in the types of facilities, and there's greater consistency. What I want to do now is illustrate the way we tried to work with the city of Minneapolis to extract information from purposeful samples that they've collected according to the National Bike and Ped Documentation Project. And so, since between 2007 and 2010, and this was launched a lot because of the national pilot non-motorized transportation program with large investments in bike and ped facilities in the Twin Cities. TLC and DPW began recruiting volunteers to count. And they've counted a little over 259 locations, and they've done replicate counts at some of those places. They've done 12-hour counts with volunteers 43 times, and they have 2-hour peak out periods, 352, and you can see the location. The locations are all purposefully chosen, typically because they were making investments in street treatments there, and they wanted to get some idea of volumes of people where they were looking at. And once they've sort of tabulated these, the DPW lacked resources to integrate the data set and extract information. So we had a team of students in a class work with this. It turns out that over that time, they have stratified those sampling locations by street functional class. And some of those have bike facilities and others don't. So keep in mind, this wasn't a randomized sample plan. This was not sort of a purposeful plan to try to get a sample across the city so it could extrapolate to the entire street network. But this is what they have. And so what we were interested in working with them to see what you can extract from this. This is the time signatures from their 43 12-hour volunteer counts, and it's juxtaposed against one of the trail counts. So what you can see is the amount of information you lose if you're going to move into working with volunteers on a 12-hour count, but you can still see some sort of a signature here. This is pedestrians, and this is bicycles. And so you see the morning and afternoon peak on the streets, but you see this noontime peak from the hours of the ped counts that you don't see for bikes. And on the trail, of course, where you have the 24-hour time signature, you don't have the noon peak. These are simple just ratios to illustrate the proportion of bike and pedestrian traffic from those 43 observations, and the R squared with the 12-hour sum. And what we chose to do is use these ratios to convert the 5 minutes, good. Convert the 2-hour counts to 12-hour estimates. This illustrates the difference in traffic between bifunctional class of their observations with a bike lane and without a bike lane. And you can see that they're different. Wherever there's a bike lane of the street functional class, they have higher volumes. They don't know if that's because they've attracted the riders or where they put them where the riders are. But this is sort of an outcome right now. And if we develop the same sort of model where we try to calculate around each of those sites, the street functional class, whether there's a bike facility, we look at the year of count, we look at neighborhood characteristics, we can develop a model. And what we've done is predict the range of bike ped traffic on streets and sidewalks in the city of Minneapolis. And we've done this, we've just stratified it by ranges. And you start to see the importance of downtown, you start to see the interiors, you start to see as you get further from the CBD, less traffic, more local traffic. So these are the estimates. This is a first generation model. And it represents a start towards extraction of information. I think it's more useful for looking at correlates of traffic than actual prediction. We see that some of these factors matter. But you see when we try to actually then, we re-estimated the model with 2007 through 2010 data, 9 data, then predicted 2010. And you can see we're really bad compared to the trail models, right? You can see like some of these days we're maybe 100% off. And so I'm not as confident in this surface, but as a first cut towards working with data that weren't collected for this purpose and try to understand a relationship, I think it's progress. It turns out that the city has recently done video. They have video summaries of pedestrians and bicyclists as a result of, I think it's 12-hour videos they've done for signal timing at 800 locations. And so potentially we'll be able to augment this data with much more robust information and again, same approach. So you can see what we're trying to do here is think about the relationship between mode, facility, time, space, and develop these statistical measures for moving it. And a street network it's just much more difficult to deal with that. So our observations. There's multiple methods available for counting, and all our counts are going to be wrong. The question is, how are we going to calibrate and what sort of calibration we're going to do? Traffic varies temporally and spatially, but consistently, at least in these trail facilities in two major Midwestern cities. Our statistical models are explaining variation. Our models aren't fully specified. We have limited observations there. But it's a good time to be doing this work because this type of work is growing, I think, quite rapidly. Krista's work represents a good extension of trying to think about the more technical aspects of this and dealing with uncertainties. Bob Schneider in Berkeley is doing a lot of work developing similar types of models. And we have opportunities to harvest data and begin to work with our local jurisdictions to address a number of real challenges. So we're hopeful that we can replicate, we can come up with bicycle and pedestrian miles traveled for the entire trail network in Minneapolis Park and Recreation Board by moving to a 2-week sampling period per trail segment for the entire forthcoming year. There's people at the Rails Trails Conservancy who are interested in looking at the same type of trail data. NOAA identifies 9 climatic zones across the United States. And they're interested in pooling that data to look how these adjustment factors, the seasonal factors, vary across geographic regions. So there's a lot of interesting things going on. I think it's both interesting and useful. And I think that one of the things that we can benefit from is shared information and working to integrate data sets so you can do broader analyses. And I'll stop there and see if there are any questions. Okay.
On the slide early on that was quality assurance / control, you were talking about how the students went out and kind of checked to see how accurate the other counters, the electronic counters were. And I have been working with the kind of signaling data you were talking about where there's video and checking the actual video against students' counts of bicycles coming through. And what I found is students are very often undercounting. So I wondered if if you're certain that it's not just that the people are inaccurate.
Well, that's a good question. The question is, can we use our standard to validate the equipment people? And we've done sometimes where we've had 2 or 3 people at the same time counting. And what we've tried to look at inter-observer reliability. And I think that depending on what you're trying to count and where you're trying to count, you can have better or worse. Like I've seen some estimates of 25% human error when you're doing very complex turning movements and where you're doing very large volumes of bicyclists and pedestrians. I think that the volumes that we're talking about, we've had people in the error range of 1% to 2% when we put them both at the same place. And that may be more a function of volume there, but that's, it's one strategy, and at least we're trying to think about that. Yes?
Quick follow-up on that. Were the students paid, or was it a grade?
Well, there was some of each. So we had research assistants with a couple people doing independent studies. Other questions?
I was on some of your graphs where you have your models for weekly traffic in Minneapolis. There's a really close correlation on Tuesdays, and then it seems like the error spreads out from Tuesdays. So I'm wondering what that means or why that's happening.
I think that is, I don't know the answer specifically, but I think it has to do with a function of the array. We're regressing towards the mean, and we're worse at the extremes of the prediction. I think that's part of the explanation for that. I don't know that, that the prediction, you see that we're consistently off more when we're trying to do higher volumes with the model, and the Tuesday is more of a moderate volume in that case.
I had a question about the trails. Obviously, with the central business district, most people aren't going to be wanting to go through there. Just as an example, as a city planner for Kalama, we've changed some of the tax codes for the Port of Kalama to use that money to build parks and use trailways over the railroad tracks and things like that. So we've been able to do that. But my main question is, how do the multi-use trails, if at all, connect with public transportation? And if so, is the usage higher in those areas?
In Indianapolis, there's very little connection because the transit system isn't very strong, and most of the use is recreational, so you don't see that. In Minneapolis, you'll see greater connection, and you'll see people moving, for example, onto a bus with a bus carrier, in some cases the light rail, because the greenway would connect with a light rail stop. And so you'll see some of those connections. But it's not extensive, would be my judgment.
Okay, thank you.
Well, you did look at, well, I'll stop there. Go ahead.
I'm just curious about future plans for maybe installing continuous counters on roadway network.
Mm-hmm.
Are you thinking of doing any of that?
Yeah, that's going to be the priority for MnDOT, and also I think the city of Minneapolis and maybe a couple of the other cities there. Which there are a couple. You know, MnDOT is going to look at investment of these as principally as pilot to demonstrate to local jurisdictions so they can get useful information. And they're extraordinarily sensitive to doing everything in Minneapolis because everybody else in the state says, that's Minneapolis. You know, that's not us. And so we need to think about that. We also need to think about working across the state in some of the other cities. And so I think that what they'll look at is purposefully choosing a set of places where they can look at loop detectors both in bike lanes and on streets generally. And in Minnesota, there are places, particularly in rural communities, where you would expect people to ride on wide shoulders. Like if you go out of Duluth, along the north shore of Lake Superior, you have scenic, basically the road is a scenic bikeway. And so they're going to choose those types of locations to try to look at that sort of variability. I also think that the city of Minneapolis will invest in some of their own, or there'll be some partnerships there. So there may be one or two there, but that won't be the state's focused. And the other thing I think that they'll try to do is look at methods of trying to look at sidewalks with passive infrared, because that's something where they have very little information. Everything that they have comes from turning movement, manual observations.
You had one slide where you had the manual counts as a function of some type of automatic counter. Mm-hmm. The correction factor, was that the regression equation?
It was a regression, yeah.
Okay.
Basically, we said we were looking, I mean, this question is relevant. Do we think our volunteers or our students and our RAs who we're counting are accurate? Mm-hmm. But what we tried to do was look at we tried to look at the magnitude of undercounting associated with the infrared counter, or in the case of the loop detectors, the overcounting. And then what we did is we ran a simple correlation.
Okay. Thank you.
I have a question on, I guess, in terms of where you see this going. You presented, you talked at the beginning about a lot of the municipalities and agencies having limited budgets, and these are preliminary models. And as this matures, what level of effort do you think it will be for a city to monitor its bike and pedestrian activity? Do you see that being something that a city would have resources to do, or would that be maybe at the local university who would continue to crunch all the data?
Well, the state of Minnesota is reinvesting in it's a Chaparral system for management of all their data, their traffic data. And one of the things that they're interested in is integrating these data so that they could be reported systematically. And the goal then would be to try to institutionalize bike and ped data in the same way so that the state is generating the adjustment factors that local jurisdictions would use for jurisdictions of different size and different types of facilities. And I think that the state's interested in that because they have set a set of objectives. They have the state strategic plan talks about increase in mode share. They talk about performance measures. They talk about a variety of factors. And so I think that they're interested in trying to develop some consistent methods so that people can look at this. I don't think that most jurisdictions will have the resources to do much other than just simply get count measures, what they need for a project-specific application. So it'll be that sort of a collaborative. The state did do this past fall, analogous to some states like the state of Washington, where the DOT there works with a bicycle group to do the National Bike and Ped Documentation Project approach. Minnesota did that. About 30 communities across the state participated. The numbers are very low, like the places you have 0 pedestrians for like a 2-hour period or four bicyclists. And so I think that now I'm going to really conjecture. I think that one of the challenges that they'll face is at some point saying almost a triage approach, that if you're in this size community at this size, we aren't going to worry about that. It's just not going to be something they can afford to deal with. And part of this other information, I think, will help them make those sorts of choices. So that's where that's moving. I think for particular uses, you'll see things move ahead. In Minneapolis, the Met Council helps fund all the park systems. And they've historically done park entry counts. And they've rotated those over several hundred locations on a multi-year rolling basis. And they use basically an adjustment factor approach to estimate. And I can see that if the larger park districts move to more systematic, better counting, that system might be replaced. But again, that's talking 10 years out because it's just only now at proof. If Minneapolis goes and estimates we're successful in getting average miles traveled on their entire system, that would be new for the state for multi-use trails. Jennifer, you had a question?
Sure. Well, one quick observation. I think you rightfully several times distinguished different patterns between bicycle and pedestrian travel. And one that I noticed towards the end you had when you predicted volumes across the Minneapolis network. I think the bikes were on the left and pedestrians on the right, or vice versa. And there were some very clear differences of places where you have much higher ped traffic and not bike. And so I think I just want to emphasize that point, that I think too much in the past we've lumped those two modes together, and what your research is showing is that there are often very different patterns. But maybe my question to you is, so you were in Indianapolis for a while doing a lot of work and analysis with the trail data, and now you've been in Minneapolis doing some similar work. So clearly those are two examples of a nice university-city-region partnership. But what happened to Indianapolis after you left? Do they still use their data? Does it get analyzed? Or
they maintain 6 of the counters. So they've stopped doing a lot of those. And if you think about that initial picture showing the variability, the park district chose the ones that they thought were most relevant for their purposes. And the university has continued to collect those, but the extent of the work is sort of monthly volume reports. and the sort of reanalysis of the data to look at multi-year trends. That's the thing that, unless there's somebody else with time, resources, imagination, that's the thing that goes by the wayside. And that's the thing that's really hard. Like, even with the work from DPW and Transit for Livable Communities, I think the students who worked on that as part of a capstone project, they got 200 or 300 spreadsheets, that they had to integrate all the data, because that's the way that they'd been being collected, and they hadn't been integrated into a single database. So I think that the state, a useful role for the DOT, if they can do that, is to begin to collect this information in some systematic way, so that they would provide that, because that's the only place where there's capacity to do that in the long term. Develop a sort of adjustment factors like Krista was illustrating yesterday.
To what extent do you see public awareness as a goal out of this project, and how might that be measured?
That's a real interesting question. I think, frankly, and now I'm going to speak personally as much as academic, I think one of the great values of doing the National Bike and Ped Documentation Project type of activity is simply that you engage citizens in the production of information, and that you engage them potentially in governance. Okay, I come from a school of public affairs, and there's interest in how you engage citizens responsibly in public planning and decision-making ways. And if you're all planning, many of you are planning students, about the citizen participation ladder, those types of things, right? Well, in some fields, and they call it citizen science, there's articles in Science and Nature based on data collected by volunteers. A lot of that is in the field of conservation biology, where people can be trained to look at the distribution and abundance of species. Sometimes we've worked with, I've been in meetings where people have been highly critical of the engagement of volunteers in this sort of an enterprise, partly because maybe like if there's huge volumes, if you have 10,000 people in an hour going past a count, it's terribly difficult to count. But the other is whether or not you can train them to count adequately. I think that there's a value to that, and because it increases awareness of the importance of thinking about these systems, and it also helps people deal with the complexities. We went out to a little town called Marshall, Minnesota, maybe, 5,000 people, 10,000 people, and the district engineer from MnDOT was beside himself because they put $800,000 into an underpass to get bikes and peds across to a high school, and he thought it would never be used. And there was no evidence that it was being used, and that might have been a connection. But if people count, they're going to make those, sometimes it's going to support systems, sometimes it's not. But I think helping people understand the importance of information, however limited, is a useful thing. That said, there's all sorts of caveats with that data. Krista outlined those, like I illustrated here, how they're very difficult to work with. But I think engaging people is a good thing generally. That's more of a personal value than it is an analytic one.
Okay. Yeah, I just wanted to know if you could comment regarding potential of loop detectors to collect bike count data. I realize that we have a lot of loop detectors, and when projects are built, is it worthwhile to think about always adding loop detectors for bikes as a means to collect useful data?
I think that it's important to install them. I think it shouldn't be done willy-nilly. There should be a systematic plan to figure out where you're going to put them and what you're going to be able to collect and who's going to analyze them, so you address the questions, the resource questions that people are talking about today. But I think they're important. And one of the things I think is important for this overall is our technologies are improving. For example, several years ago, there were very few loop detectors in streets. We're looking at actual counting because they were worried about distinguishing bikes and peds. I mean, that's why there are none in Minneapolis, St. Paul, where they're done specifically for counting. There's activation and other things, but they just haven't got that far because people have been uncertain about the ability of them to perform. And I think that the ones that we're using now, that the newer generation technology will be much better. And I think that, for example, you can buy now integrated bike ped counters, it will help eliminate the problem that I identified of having two different manufacturers' products side by side that gave you irreconcilable data.
I think we're about time.
It's my pleasure.